right, so here's an example of, I don't know, a different kind of problem. So I don't have it written for you, but at a stoplight, a large truck, 3,000 kilograms, collides with a motionless small car. Okay, so a large truck of 300 kilograms. Okay, so truck, car, collides with a small car of 1,200 kilograms that's motionless. Okay, we're probably going to look for this. Let's see. Okay, so that's our before. Okay, after it says the truck comes to an instantaneous stop. Okay, and then the car flies off. Oops. Okay, let's see. The truck comes to an instantaneous stop. The car slides straight ahead, coming to a stop after sliding 10 meters. Okay, so they're not telling us the velocity, but they are telling us that it's coming to a stop after sliding 10 meters. Okay, the coefficient of friction is 0.62. Okay, how fast was the truck moving at the moment of impact? Okay, so that's actually this, right? Because this is how fast was it going before they hit. Okay, all right, so as soon as you see that it's a collision problem, you know there's going to be something with momentum. Even if you don't end up solving this first, right, you can still write it. Let's see what we got here. Okay, so truck and car, mass of the truck, V truck final, plus mass of the car, V of the car final. Okay, so that's going to be 0. All right, what I'm ultimately looking for is the initial velocity of the truck. Okay, so let's see. I have all the masses, so that's terrific. Okay, this is 0, so let's get rid of that. Okay, and I don't know this either, right? So that means I'm going to need to find some other way to get this velocity so that I can backtrack it and get the velocity of the truck. Okay, so let me leave some space. So I'm going to have MT VT initial is going to equal M car V car final divided by mass of the truck. Okay, so here's what I'm looking for. Okay, I just need that final velocity of the car. All right, so it tells me that it's coming to a stop. Okay, so since I get the coefficient of friction, I could be thinking some kind of kinematics, okay, which will work, I think, depending on what they gave you. But again, that's kind of hard. So if you really want to think of it, you have your car moving, okay, and then you have your car stopped, right? So you're going to have some kinetic energy to start with, turning into some thermal or some work done by friction. Okay, so the K is going to equal either the work done by friction, or you can call that E therm, whatever you want to call that. So that's going to be 1/2 mv squared plus the force of the friction times the distance. Okay, so let's see if we have enough stuff to solve for this V, and I think we probably will. Okay, so V squared is going to be equal to force of friction is just going to be mu mg, because it's not on a hill, there's no extra forces or anything. Okay, divided by m. The m's are going to cancel out, which is fine. We had it anyway. Who cares? Okay, so V is going to be radical 2 mu g d. No, nothing on the bottom. Okay, so 2 times the mu is 0.62. I'll just use 10, even though you can use 9.8 if you want. Okay, and then the distance, well, I'm going to put 9.8 just so you don't get confused because the other one's 10. 9.8 is the G, and then 10 is, I think, the distance that it said it slid. Okay? All right, so again, why don't I just go get the actual calculator? 2 times 0.62, whoops, 0.62 times 0.62 times 9.8 times 10, radical, like about 11 something, 11.0 meters per second. Okay, now let's see if that makes sense, right? So that is how fast was the car going, or how fast, oh, we don't know how fast it was, so we can't. I was going to try to compare that, but we don't have anything to compare it to yet. Okay, so that's 11 meters per second. Okay, so now I can just go ahead and finish solving this. The mass of the car was 1,200. The velocity of the car was 11. The mass of the truck was 3,000. Okay, so the initial velocity of the truck, 100 divided by 3,000, okay, is 4.4. Okay, and that's slower than the car, which makes sense because it was bigger, right? So then we know that this is going to have come in at 4.4. Okay, all right, so that's just an example on how you might have to combine momentum with something else.